Welcome to lesson 5.2, graphing linear inequalities in two variables. So our last lesson we were looking at quadratic inequalities. Now we're moving back to linear, which means we're going to be working with lines instead of our parabolas in this case. And here we are working in two variables. So there's a couple things that we need to cover before we go ahead and start solving these kinds of questions. So we have linear inequality in two variables can be written in general form as so. We have our ax plus by plus c here is greater than 0. We also have it less than 0, greater than or equal to 0, and less than or equal to 0 are four inequality signs. Now a, b, and c are all constants here, and the graph of a linear inequality is all the ordered pairs x, y that satisfy the inequality. So special note, all the ordered pairs that satisfy the inequality. Now when we're graphing the inequality, there's something we need to make a note of, because this is very important. When we have the signs of less than and greater than, they're going to be represented by a dotted line on the coordinate grid. So when we go ahead and graph these kinds of inequalities, we need to use a dotted line like this. Now when it's greater than or equal to and less than or equal to, it's going to be represented by the solid line on the coordinate grid. So it'll look like this when we're graphing it. That's where we can tell whether one is only greater than or less than, or when it's greater than or less than and equal to. Okay, so now looking at our steps here, we have a bit of a review on how to graph our linear equations here. So graphing the line on the coordinate grid, we use y equals mx plus b form of the line. Now remember that m is our slope here, which is our rise over our run, and b is our y-intercept. So that is the common form that we use on graphing our lines here. Now we need to identify if it is a dotted or solid line. Next we need to choose a test point that is not on the line. And there's a hint. It says use 0, 0 unless it is on the line. So just like before in lesson 5.1, we need to test to see where our inequality is correct. So, and it says that 0, 0 is generally the best point to use, as long as it is not on the line. Now, step 3 says substitute the test point into the original equation. If it satisfies the inequality, shade on that side of the line where the test point is. However, if it does not satisfy the inequality, this should say inequality, shade on the opposite side of the line. Alright, so let's take all of this and apply it to a question so we can get a better understanding of what it really means. Let's look at our first example here. Example 1. Graph the inequality x minus 3y is greater than 6. So let's work in our steps here, and first I'm going to put it into y equals mx plus b form so I could go ahead and graph it. So rewriting, we have x minus 3y greater than 6. I'm going to move our x to the other side, and we're going to get minus 3y greater than minus x plus 6. Now I got to get rid of the negative 3 attached to the y, so I need to divide by negative 3. Now remember, when you divide or multiply by a negative, our sign changes direction. So make a note of that. Sign changes. So now we're going to have our y being less than 1/3 x minus 2. Now we have it in y equals mx plus b form with a slope here of 1/3 and a y-intercept of negative 2. So going to our graph, negative 2 is about there, so that's our x, that's our y-intercept, and we have a slope of 1/3, so we're going up 1 over 3, up 1 over 3, up 1 over 3. We can also do this in the opposite direction, going down 1 over 3, down 1 over 3, down 1 over 3. So we're getting something like that. Now remember, it was greater than or less than inequality, so we want it to be a dotted line here. So make a note of that. It has to be a dotted line. So sketching that out, we're going to get something kind of like that. Awesome. So our second step says choose a test point that is not on the line. Well, in this case, our 0, 0, which we would generally want to use, is not on the line. So let's test our 0, 0. And now, step 3 says to sub it back into the original equation. Now, we get that 0 minus 3 times 0 is greater than 6. Well, when we go ahead and solve that, we're going to get 0 is greater than 6, and that is not true at all. So, looking back, our step says if it satisfies the inequality, shade on the side of the line where the test point is. And if it does not satisfy the inequality, shade on the opposite side of the line. Well, in our case, it did not satisfy the inequality. So we need to shade on the opposite side of the line. Well, and since 0, 0 is right here, we need to shade below the line, the opposite side. There we go. We graphed our linear inequality there. So let's do another example here. We have a little word problem. Carmen has up to $15 to buy seeds. A package of vegetable seeds costs $1.50, and a package of flower seeds costs $2. Write an inequality to represent the total cost of the seeds and then graph the inequality. Alright, so since we have a word problem here, we need to choose variables to represent our subjects. So here we need to let's say V equal the number of vegetable seed packages, and F be the number of flower seed packages. It's saying we have up to $15 to buy seeds. So we know that we have $15 and we have up to it, so it has to be less than or equal to $15. Well, and it's saying we have $1.50 for vegetable seeds, so $1.50 per vegetable seed, and $2 per flower seed, and 2F. From there we get our inequality. $1.50 per every vegetable seed plus $2 per every flower seed, and we have up to $15. Now I need to make a special note here. We cannot have our values of V and F be negatives in this case, because we cannot buy a negative amount of seed packages. So we need our V and F to absolutely be greater than or equal to 0 for this question. Now from there we can go ahead and use our steps to graph the inequality. First step, we need to put it into y equals mx plus b form. We get, well, since we have v and f instead of x and y, I'm just going to choose one to equal y, and I'll just choose v in this case. So we're going to get $1.50 v plus 2f less than or equal to 15. Now 1.50 v less than or equal to negative 2f plus 15. And solving for v, we are going to get v is less than or equal to negative 4/3 f plus 10. Now, even though we were dividing by a decimal here, I kept it in fraction form because that way I can see my rise and my run in my slope. So making a note here, our slope is negative 4/3 and our intercept is 10. So starting at our y-intercept way up here at positive 10, we have a rise over run of negative 4/3. So we're going down 4 and over 3. Down 4 and over 3. Down 4 and over 3. So we're going to get something like that, and making a note that it is a less than or equal to inequality, so it's a solid line in this case. Ooh, that is not a very straight line. Anyways, that is what our line should kind of look like. Our next step here is to test a point to see where we need to shade for our inequality. So nicely enough, 0, 0 is not on our line, so let's test 0, 0. And we're looking at our original equation. We have 1.5 times 0 plus 2 times 0. Well, here we just get 0 less than or equal to 15, which is true in this case. So that means we need to shade where the test point is. And the test point is here. So we're shading below our linear inequality. So we got all of this to shade. There we go. We found our inequality and we graphed it. However, we have a few other questions we need to answer. Part B asks us to determine 2 possible ways Carmen can spend up to $15. Well, here it's just asking us to find 2 points that she can use that satisfy the inequality. Well, since we determined that everything below the inequality is true for it, we can just pick any point in that area. So, for example, we can pick our test point that we chose, and we can say that she buys no seeds. Another example is that she buys, let's say, a 0.26, where it means that she bought 2 packages of flower seeds and 6 vegetable seeds. Another example could be 4-3, all satisfy her spending up to $15. And there's so many choices that you can choose. These are just a couple examples. Part C asks, can Carmen buy 5 packages of vegetable seeds and 4 packages of flower seeds? Justify the answer. So this is asking us for a point of 4, 5 on our graph. Well, if we go up and look at our graph, we can see that 4, 5 is somewhere around here, if we drew the graph accurately, and that is not in our shaded region. That is not falling below our line here. So we can say that it is not a possible purchase. So no, she cannot, because it would not satisfy her $15 budget. Awesome. Our last part here is asking us, what is the most money Carmen can spend and still have change from $15? The most money she can spend with still having change is something that's going to be closest to the line, but not on the line. Because if it was on the line, we wouldn't have any change. So if we went ahead, looked back at our graph, you can actually find a couple that you could use. And when I went ahead and looked at the graph, I found one at 2. So when I went ahead and plugged those points in to the inequality, I found that I got an amount of $10.50 plus $4, which is $14.50, leaving me with a change of 50 cents. So that is probably the most I can spend with still having change. And there we go. That is a couple examples of solving linear inequalities using our graphs.